Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at surface area. So we are interested in calculating the surface area of 3D shapes, so prisms, spheres, cones and the like. So I've started off with a rectangular prism, which is probably the easiest 3D shape. See what the surface area is, it's the sum of the area of each of its faces. A rectangular prism has 6 faces. We just find the area of each of those, add them up, that is the surface area. You can think of it as like if I were to wrap this up in wrapping paper, what is the minimum amount of wrapping paper, the minimum area of wrapping paper that I would need. Now, some people find it helpful to deconstruct these shapes into nets. So if I flattened out this rectangular box here, it would look like this. So what we would have is this one here is the face on the bottom. So of course the area of this is going to be LW, LW for here, and so on. So if I want to find the surface area, I just add up all of these. And from that, we can get a convenient formula. 2LW, 2 times length times width, plus 2 times length times height, plus 2 times width times height. See, that's because there are 6 faces and they come in pairs. 2LW is this face here at the side, and then on the other side, 2LH. So L times H is at the top and the bottom, and then 2WH, the front and the back. So let's use this formula here to calculate the surface area of this shape here. Now I'm going to say that this shape here is closed. What that means is it has all of its faces. The surface area would be different if I were to say take off the top. So you need to know before calculating surface area whether it's closed or open. Open meaning it doesn't have a top. So this is closed, it has all of its 6 faces. I'm going to use this formula to find its total surface area. So we call total surface area TSA. It's 2 times length times width plus 2 times length times height plus 2 times width times height. So if you put that straight on your calculator, you get 248, and it's going to be meters squared. This is surface area, so it uses squared units. All right, let's now look at finding the surface area of some other shapes. So let's find the surface area of each of these 3 shapes. Now I'm going to assume all 3 of these shapes are closed, so they have all their surfaces. So here we have a cylinder. So if I were to draw the net of a cylinder, it'd actually be a rectangle and 2 circles. These 2 circles at the top and bottom are how I get 2 pi r squared, 2 circles, and this rectangle actually has 2 pi r as its length. So the circumference of the circle is the length of the rectangle, and then h, the height of the cylinder, would be the width of the rectangle. So you might choose not to use nets, which is fine if you just want to use the formula. But either way, the surface area is going to be 2 pi times radius squared plus 2 pi times radius times, and it's always perpendicular height whenever you see h in a formula in measurement. So if we put this on our calculator, I'm going to round it to 2 decimal places. It's about 402.12, and we're just going to write units squared because we don't know whether it's centimeters, meters, whatever. That's how we do that one. All right, now let's look at the total surface area of a cone. So it follows this formula here. Pi r squared is the circle up here. Pi rs is this curved surface there. So we know that the area of the circle at the top is going to be pi times radius squared, pi times 2 squared. So that's the area of the circle at the top. Now the curved surface is pi times radius times s. S here means slant height. So here 4 meters is the slant height. So again, we can just put this straight on our calculator. So this time I'll give the answer to 1 decimal place. It's about 37.7 meters squared. All right, the total surface area of a sphere, which is really hard to make a net for, but the total surface area of a sphere is just 4 pi r squared. So the radius of a sphere is the distance from the outside of it to the center of the sphere. So here the radius is 6, so the total surface area is just 4 times pi times radius squared. So again, I'll just give it to one decimal place. It's 452.4 centimeters squared. So again, surface area, think of it, if you got someone a present that was a sphere 6 centimeters, you would need this much wrapping paper to totally wrap it up. All right, let's look now at some harder questions where we're finding side lengths. So let's look at this question. A rectangular prism has surface area 158. Calculate the length if height is 3 and width is 5. So I've previously told you how to approach these questions in which you have to find a dimension, like a side length, from the area, surface area, volume, whatever. The first step is always to write the formula. So the formula for the total surface area of a rectangle is 2LW plus 2LH plus 2WH. So that's the first step. The second step is to substitute what you know. Well, the question tells us that height is 3 centimeters. So everywhere I see a H, I'm going to replace it with 3. Similarly, everywhere I see a W, I'm going to replace it with 5. And finally, we were told that the total surface area is 158, so I replace that with 158. I now have an equation that has just one variable, so it can be solved pretty easily. Just making this a little easier to read, 158 equals 2L times 5 is 10L, plus 6L, plus 2 times 5 times 3 is 30. So to solve this equation, I subtract 30 from both sides. 10L plus 6L is 16L. I undo timesing by 16 by dividing by 16. I get L equals 8. So that means that the length here is 8 centimeters. Okay, let's look at the next question. Calculate the radius of a sphere with total surface area 200. So first step, I'm going to write the formula. Total surface area equals 4 pi r squared. So now I'm going to rub out total surface area and replace it with 200. See, that's all I need. This is an equation with just one variable, so I can solve it. First step is to divide each side by 4. I get 50 equals pi r squared. So I have to next undo pi because squaring comes first in BIDMAS before multiplication. So multiplication is what I must undo first. So dividing each side by pi, I get 50 over pi equals r squared. And now I square root both sides. Of course, the square root of r squared is just r. So the radius here is the square root of 50 over pi. So this here is the exact value, and if I put it on my calculator, I get the radius is approximately 3.99 centimeters. So just under 4 centimeters for the radius. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.